Bismillah ar-Rahman ar-Rahim. We have today is our first session. I call this session because sometimes we have two experiments in one session. So we'll start with experiment number 2 in the book. This is the book which we explained to you last time, last week. And preliminary introduction, we told you about the experiment in high voltage book. So in the beginning, we'll just have very back, because I assume everybody don't have, somebody took this 446, somebody don't take it. So I'll just give you very brief talk about different kind of insulation material. So we have solid, we have liquid, solid like porcelain, glass, whatever, liquid oil, mainly oil and water, gas, SF6 air, nitrogen, vacuum, where there is no material at all, and composite, which is two of these combined together. So in high voltage, we have breakdown voltage. In the beginning, like high voltage normally deal with the insulation. Most of the time, high voltage technology, high voltage engineering is mainly insulation engineering, because it deals the problem associated with the breakdown of insulation. So what is breakdown voltage? It's the maximum voltage before a breakdown. You are raising the voltage, at one moment it will break down, so they call it breakdown. What is dielectric strength? تحمل العازل أو تحمل العازل أو متانة العزل الكهربائي الترجمة الكاملة. It's maximum E, which is electric field before breakdown. Now we come. So here, electric field in communication and basic electromagnetism, it's electric field. We call it dielectric stress, because in our case it is stressing the insulation. So it is stressing the installation. So this is dielectric stress, and these cause the stress. I mean, the V is causing the stress. It's causing the stress. There is no V, there is no V. So dielectric strength. So V is associated with A. When you have voltage, you have electric. What is dielectric strength? As we mentioned before, it's the maximum electric field. So we'll have higher dielectric strength, better insulation. For example, 1 centimeter of air can take 30 kilovolt. So the dielectric strength of air is 30 kilovolt per centimeter. Each 1 centimeter, if you apply more than 30 in the air, it will break down, become, instead of insulation, become conductor. And oil can take up to 500 kilovolt each centimeter. The pure oil, the good oil. SF6 أو about 140 140 kilovolt per centimeter لما يكون الضغط at normal pressure 1 bar. Now in our experiment, how to find or how to measure dielectric strength. Before we talk about this point, I think this one comes. Before we talk about this one, we have to find, maybe go back to the course. You know, electric field can be divided to uniform field and non-uniform field. What is uniform field? If you have two parallel plates, infinite parallel plate, horizontal and parallel, you will have electric field. So if you have 100 kilovolt here and 0 ground here, you will have the equipotential lines or equivoltage line, which is, it will be straight lines. For example, this is 80, 60, 40, 20, 0. And what is the perpendicular المتعامد عليها يسمونه electric field line. So if the electric field line become parallel, they will call it equal or potential lines or equal field or uniform field. So electric field here, what is the electric field? Is 100/5, so 20 kilovolts per centimeter. So it will be 20 here, 20 here, 20 here, any place. It's opposite. If you have rod to plane, you have point plane. This is a high voltage into ground. If you draw the equal potential lines, equal voltage, you go to electromagnetic course, you will find it in this way. It's like, so the electric field line will be perpendicular, so it will be like a ish'a. So for sure, when the electric field line close together, that means electric field is high. When they are far away, electric field. So here it is very high, here medium, and here low. So this is the difference. Of course, when we want to measure the dielectric strength, we have, shall we use uniform or non-uniform? We must use uniform, because non-uniform we don't know. So in uniform, we apply voltage. We have 1 centimeter gap, air for example, 1 centimeter gap, infinite parallel plate, and this is AC supply for example. We increase the voltage until it has breakdown. When the breakdown happens, this reading, that means it is the dielectric strength of air. Of course, this is not practical. I will show you why it's not practical.